People love surprises. And one of the things we want to do as human beings is to understand the surprising things that surround us on an everyday basis. These have to do with the environment, human medicine, ancient geological history. Every aspect of our lives is full of surprises, and we want to understand them better. So the process of being able to approach these kind of surprising aspects of life we call science. And science is really defined as two primary things. One of them is that the approach needs to be reproducible. In other words, if you do a scientific analysis, you need to be able to do it again and again and again, have it yield the same results. Another definition of good science is it predictive? Is it capable of giving you the ability to make predictions into the future and have those predictions be accurate? What comes to mind first, of course, is things like weather forecasting. And we all know what it's like to go out of the door without an umbrella and then needing it immediately as soon as we get to work. So we understand the needs of reproducibility and prediction. But fundamentally, what that process of going through scientific analyses does, instead of it really being a straight line where you have a question, you run an experiment of some type, you get results and you interpret it and you have an answer, actually the forward progress is much more like a spiral. It's like a process that's very systematic, but it's a systematic process that is spiraling ever closer to truth, understanding how something really happens, but having that be sought and understood via a process that is always spinning on itself and giving you more and more insights which bring you closer to the truth, but at the same time it gives you even more ideas of what you don't know, and it gives you even more and better new questions to answer in the future. So we call this process scientific inquiry. And that scientific inquiry is a very systematic, logically a followed pathway which spirals. And each time you follow the pathway and the spiral, it brings you closer to understanding what you are trying to analyze and make predictions about for the future. So let's break this down a little bit in terms of how real science works for most people. The first one is you want to initiate curiosity. You want to use this supercomputer that's on your shoulders called your mind. And that is an amazing tool. And that tool lets us think in the dimensions of X, Y, and Z, the 3 dimensions of space, and it also lets us think through time. And so running the experiments, thinking about questions, what is valid, what is relevant, what is worthwhile to actually analyze, we call that initiate curiosity. Well, once you come up with these key questions and the key hypotheses you want to study, then you want to reason, plan, and hypothesize. You want to say to yourself, is this an answerable question? And are the kind of analyses that I'm proposing to do, is my logical mind experiment suggesting that the results will be valid and the results are actually doable? And can I frame my questions into a really strong hypothesis? Then once you go through those 2 first steps, then you're ready to actually do the experiment. And experimentation takes a lot of time and a lot of money. And so you don't want to get to that point until you're really ready to do that work. Then you run the experiments and you get data back and you have observations. So the next step is you want to synthesize or combine observations and data into a format that will allow you to interpret and then discuss the results. Now, once you bring those all together and you have an idea of what some of the answers are to the questions, the hypotheses you were testing, then you want to share those with other people. And we call that communicate results. That can be done to speaking to people you know. That can be done in a written format in the context of books or journal publications. It can be formal communications, presentations at conferences. There's many ways to communicate, but the vital thing is the results must be communicated, because good science that is not communicated, no one can know it, and it hasn't contributed to the greater good of why the science was done. And then finally, you want to go back and modify, rethink, and reinitiate your initial curiosity. Hey, what are the new exciting things I've found? What are the things that are totally surprising, that are unexpected? And what can I think of that would really be the most relevant, important, and worthwhile thing to do with time and money in terms of moving forward with the type of scientific questions that you have? So this brings you to the next point of initiation. And then you go through the spiral again, and each time that takes place, you're getting closer and closer to what the truth is. An important aspect of the scientific inquiry spiral is that you can't jump from one level to another. You must systematically follow it and work your way down through the spiral. Now, if you find that something isn't working, or the question isn't valid, or it's an impossible thing to answer, or it's not worthwhile to pursue it, then you start a new spiral. But if you are proceeding and actually getting information and moving forward to understand what you want, you need to systematically keep on this pathway, work your way through each step, and at the end of each of the progressive spiral levels, you are initiating into a new level of science that is rigorously defendable because you followed a scientific pathway to gain that level of perspective. So scientific inquiry is actually that dynamic template which allows us to answer the very complicated kind of questions that are required for the future of the survival of planet Earth.